Joseph Oldham. I'm the director for the CalSTART San Joaquin Valley Clean Transportation Center. And we're here at Fresno Chandler Executive Airport, and this is the Sustainable Aviation Project.
I see 4 aircraft in this hangar.
Yes.
What are these, Joe?
These are Pipistrel Alpha Electro trainers. They're specifically designed as flight training aircraft. They are battery electric, all electric. There's no internal combustion engines in these at all. And the Sustainable Aviation Project is really designed as a way of lowering the cost for flight training through the use of electric aircraft, which are so much lower cost to operate compared to older existing internal combustion aircraft, like a Cessna 150 or a Piper Cherokee, something of that nature.
Right, so these are 100% electric.
100% electric. There's absolutely no internal combustion. There's no fuel, traditional liquid fuels on board these aircraft. They have a 21 kilowatt hour set of battery packs, and they have an electric motor that's rated at 60 kilowatts and can produce as much as 70 kilowatts of power on takeoff for up to 1 minute.
That's great. What's the top end? What's the top speed?
Top speed, the maximum speed is 135 knots. The cruising speed is typically around 85 to 90 knots. I typically fly them at about 64 knots, which is about 73 miles an hour.
And that's good efficiency, good fuel, energy economy.
Actually,
right?
These get better fuel efficiency in terms of miles per kilowatt hour than my Chevy Volt.
Oh, wow.
Yeah,
wow.
These get about 4.3 miles per kilowatt hour. My Volt is about 4.
Uh-huh,
yeah.
Great.
And my Volt, I get that fuel economy as an average in-town driving. I get 4.3 miles per kilowatt hour out of these at 73 miles per hour, which is freeway speed. My Volt does not even come close to that.
Right.
Not even come close.
Not at that speed, right?
Not at that speed.
Great.
No.
I think you said that they make the same aircraft is available with a gas motor.
Yes. Same aircraft is available with an 80 horsepower Rotax 4-cylinder gasoline engine and a 13-gallon fuel tank for aviation fuel that's located behind the pilot and the passengers.
I imagine it requires a significant amount more maintenance and care.
The gas engines definitely do. Definitely do. These aircraft are basically maintenance-free for the first 2,000 hours, and then after 2,000 hours, you remove the electric motor, which is only about this thick and about this wide, and it's right here, located directly connected to the prop. You remove that motor, you check the bearings. If the bearings are okay, you put it back in for another 2,000 hours. You do that 3 times till you hit about 6,000 hours, and then you replace the motor.
Right.
So it's just, and there's no spark plugs, there's no oil, there's no ignition system. It's very, very simple.
Where do the batteries go? In the wings, in the body?
No, the batteries are located in these compartments, and I'll get the keys and I'll open them up.
All right.
See, there's one pack in the front, and then there's one pack in the rear. And we'll open those up and I'll show you what that looks like. So here's the front battery pack. This is a 10.5 kilowatt hour pack. It's got an active display that shows the temperature in Celsius. It'll show the state of charge, and then it shows the state of health, which, according to the manufacturer, basically refers to the total ion capacity or electron capacity inside the battery.
Mm-hmm. So at new or near new, it's reading close to 100%?
At 100%, yeah. What's interesting about state of health is that it'll change. It'll change with temperature, it'll change with state of charge, or the charging protocol that you do. Over the summer, we saw this state of health kind of go up, and then it went down, and then it would go up and come back, and so it just kind of fluctuates a little bit. But from what we can see, I've got over 100 hours of flight testing time in this aircraft here, and I did not see any reduction
Wow.
in my time aloft as the state of health changed. There was no reduction in flight time.
You mentioned, was it 6,000 hours for the motor?
Yeah, 6,000 hours for the motor.
Do we have an idea of the useful life of a battery pack?
We don't. We don't. The manufacturer threw out a number of something like 14 years. I think that's a little too much. I think what we're probably looking at is probably on the order of about 8 years.
But battery technologies are changing all the time, so
Yes.
8 years from now, whatever you put in there is likely to be somewhat better.
And the pack is, you don't replace that entire pack. What you do is you just replace the cells that are in the pack.
I see.
So what we would do is we'd take the packs, we'd ship them back to the factory. They'd put improved cells in them.
Get a
which would
reconditioned
give-
pack back.
reconditioned the packs, and they come
nice.
back. So, yeah.
And you said there's this pack and then another?
Yeah, there's one here in the back. They're basically identical. The two packs work together, but they can work separately. The second one's back
Oh, there.
here. Yeah, right here. Yeah, they can work independently. The battery management system on board monitors the packs, the state of charge. It doesn't monitor the state of health, or at least it doesn't show it on the display, but it monitors state of charge and temperature. And then what it does, because there's only the display only shows what you can see in terms of one pack's state of health or state of charge. What it does is it reports the lowest state of charge if there is a difference between the two, and so that provides a safety factor.
Great.
Yeah.
Are you able to charge them on board, or do you have to remove them?
No, they're charged on board. In fact, here I'll show you over here. There.
Oh, great.
Yeah.
Just like a fuel tank lid.
Yeah, just
very good.
Or just like the charge port on your Chevy Volt or Chevy Bolt or a Tesla or any of the others.
Yeah.
So, yeah. And this charge port is actually set up with a locking mechanism for the charger adapter. When you put the charger adapter in and you activate it, it puts a pin in there and prevents it from being accidentally being able to be removed.
Good.
And then this little light here glows red, and then when the charging is done and everything is, and the pin is retracted, this turns green and tells you that you can disconnect.
Great.
The chargers are 15 kilowatt rated chargers. They use a 240 volt single phase circuit.
Okay. So that would be a commercial dryer level, like a closed. I mean, 15 kilowatts would be the same as, it'd be drawing the same as 1500 watt.
Yes.
Blow dryers.
Yeah. Or about the same as your home dryer or an electric stove. Right.
So it's not an exotic level of power needed to charge these.
And it's the same basic power level that you need for most of the electric cars today.
Right.
They need they typically need 10 to 15 or 18 kilowatt chargers.
Yeah. Now you have 4 aircraft here.
Right.
Are they all in various states of are they in a testing phase? What are you doing with the 4 of them?
The reason we acquired 4 was the plan with this project was, as I said, to develop the country's first electric flight training operation, where we actually train pilots in electric aircraft.
Wow.
And there is a existing and growing pilot shortage in the United States, and one of the challenges with getting new pilots is the amount of time that it takes, flight time, in order to get the experience you need to step into an airline job, or even some of the jobs like with CAL FIRE or with the CHP or with crop dusting or any of the commercial applications. And the cost, these training aircraft that we see out here on the field, these older airplanes, some of these planes are 50 years old.
Right.
They burn somewhere around 8 to 10 gallons an hour of aviation gasoline at about $5 a gallon. So we're anywhere from 40 to 50 bucks an hour just for the fuel. And the rental costs then with the insurance and the maintenance, because these things are very maintenance intense, drives the rental costs up to around $125 to somewhere around $170 an hour. So a student coming in that needs 40 hours of flight time, 40 hours times maybe $200 an hour when you add an instructor at $50 an hour to that airplane that's $150 an hour, it really adds up.
Yeah.
And so what we can do with these cost $3 an hour to fly on electricity. They use about 16 kilowatt hours times about a 20 cent a kilowatt hour rate for a typical kind of commercial rate. And so it costs about $3 an hour to fly one of these.
Wow.
And so just on the fuel cost alone, we can reduce that cost by over 90%.
Right.
And that's huge. So that was what this project was designed to do, as well as showcase the feasibility and the viability of electric propulsion in aircraft.
Right, right. So we have a lot of benefits: lower cost, lower energy use,
Zero emissions.
zero emissions,
Zero emissions.
and you're creating here the nation's first electric pilot training facility.
Electric aircraft.
Electric aircraft
training program.
That's great.
Yeah.
Is it in the process of becoming certified to be that, or are you
Yes.
already? Yeah, great,
Yes.
great.
So part of the reason why we did 100 hours of flight testing on this aircraft was to develop enough data, generate enough data to support a petition for exemption with the FAA.
Great.
Because there's a regulatory challenge that we faced in the regulations, in the federal code of regulations. There's a stipulation that this class of aircraft, if it's basically the definition of this type of aircraft, which are called light sport, that a light sport aircraft has a single reciprocating engine if powered. That's actually in the federal code.
Right.
Well, an electric motor is not a reciprocating
Yeah.
engine. So what we're having to do is develop the data and submit a petition to get the aircraft recertified
Right.
as special light sport aircraft, so that then we can go through the process of
That's great.
using them for flight training.
The regulatory world needs to catch up with the technology of
Yes,
aircraft.
the regulatory world, and it is.
I can see the need for licensed pilots for this new type of aircraft. What are some of the and I can see applications all over the place for them, from just shuttling people about to anything that an ordinary aircraft might do. But what are some of the applications that excite you?
Well, I think the things that excite me the most is new ideas on how you might use these aircraft. For instance, because they're zero emission, they offer an amazing platform for like air quality sampling, and air testing, where you can actually use them to collect air samples, and there's no possibility of contamination. They offer the opportunity of being like motherships for unmanned aerial aircraft,
Right.
where basically they can act as the control center with a crew on board that's monitoring what the UAVs are doing. They're going out and maybe doing surveying, maybe of power lines,
Sure.
or gas lines, or
Right.
doing all kinds of other survey types of work. From an Alpha Electro, you could control that very effectively from a centralized location, and have the crew has the ability to see kind of the bigger picture that maybe a remote drone operator couldn't see.
That's right.
Because he's just limited on his vision through the camera in the drone.
Reconnaissance of transmission corridors, for example, or just general forestry purposes.
Yeah.
One of the things about this we talked about is that these can touch down at shorter than usual landing strips, and if a strip or an airstrip is equipped with say a solar-powered energy storage charging station, they don't need to worry about having liquid fuel delivered to a site.
Exactly.
So these can be deployed more broadly. And be able to touch down, charge up, get up in the air again. Yeah.
It only takes about an hour to recharge one of these.
Yeah.
Even after about an hour or so, and that is all going to just continue to improve. There's over 100 different designs from a multitude of manufacturers.
Sure.
These are just the beginning.
Yeah.
That are in the works right now. Some of the aircraft are designed to be electric vertical takeoff and landing, so they can actually perform like a helicopter. They can take off from a small site, transition to horizontal flight, and then land vertically.
Great.
Some of them are like these. They're designed to be fixed wing and have ability to glide and fly very efficiently. These aircraft have a 17-to-1 glide ratio, which is pretty amazing for a training aircraft. Typical training aircraft have about a 10-to-1 glide ratio.
So they can come in at almost half the angle for a powerless glide into a land strip if
Well,
anything.
what
If they
these
needed
aircraft have too, we have spoilers on tops of the wings that are electrically operated. So as I come in, if I want to make a really short field landing, what I can do is I can come in and I can be high and I can be coming over obstacles and I can deploy those spoilers and this thing comes down just like an elevator.
Oh, wow.
And I can then touch down. I can take the spoilers out at the last second and then just touch down nice and smooth, really slow. And I can use only just a few hundred feet of runway.
That's amazing.
Land. And then takeoff is the same.
Right.
On takeoff at full power, this thing gets off the ground at full gross weight within a couple of hundred feet.
Wow.
And then I'm climbing at 1,300 feet a minute. And so I can clear a 50-foot obstacle in a matter of less than a second or two.
Wow.
And get out of a tight spot really quickly.
Sure. Just before we go, can we take a look? You had turned the dashboard up.
Yeah, sure.
Can you take a look at that?
Sure. Open this up.
All right.
All of these gauges, even though these look like old-style mechanical gauges, they're not. They're all electronic.
Right.
They just have that look. And so what you have here is the main display for the electric power system. So this central bar is the state of charge for the batteries.
Right.
You have the total hours on the aircraft. You've got the voltage. It's a 400-volt system for the main power supply. And then you have the auxiliary voltage for the control 12-volt. This shows your temperature for the motor or for the batteries. This is for the inverter, and this is for the motor. And then this device over here is a global positioning system.
Wow, GPS.
GPS shows our exact location. Shows a lot of different things, including a flight log, shows where you've been, what you've done. Like this flight log here shows one of my last flights. Went all the way out to Madeira and then kind of came back into Chandler. Traveled about 59 nautical miles, which is pretty good.
It's a pretty simple, really simple display, isn't it?
It is. It's very simple. In fact, that makes it really easy for new pilots that are transitioning into flight training, because what this is not much more than what their experience with the simulator.
Right.
So if they start out training on a sim, to move from a sim into an actual airplane, this is the first and easiest step.
You bet. Wow. So there's really a need. You mentioned earlier a need for a real demand for qualified pilots. Period.
It's huge.
And
There's a shortage across every area of aviation.
Right.
Cal Fire is short on pilots right now, and of course we're having all of these fires in California.
Yeah.
It's putting a huge strain. There's a shortage of crop duster pilots. There's a shortage of commercial pilots. There's a shortage of flight instructors. There's a shortage of pilots in the regional airlines.
Right.
We're losing air service to many of our smaller communities and smaller cities because the regionals are losing their pilots, because the pilots that are in the international and national airlines, they're all retiring.
Yeah,
they have to retire.
right.
Mandatory 65, retirement age. So those folks are leaving, and they're pulling up the younger pilots out of the regionals, and the regionals don't have anybody to pull from.
Well, it sounds like the same problem faced by a lot of industries that need more STEM-trained graduates from high school and from colleges, and in the world of transportation, we know electric vehicles and now electric aircraft coming into being, and they're going to be taking over, and there's already a shortage of qualified personnel in the traditional world. Now it's going to be a new electric world of transportation with a great need of pilots. And as you mentioned, CAL FIRE and any number of different forestry applications and emergency services and restoration and prevention all need these pilots and mechanics and all the rest of the ancillary jobs that go to support these. Right?
We're integrating transportation into our existing built environment.
Right.
And this is where the challenge comes. For years we've had a lot of work going on with energy efficiency, renewable energy in the built environment. The electric utilities have been heavily engaged in that. Now as we transition and get our transportation systems integrated so that vehicles are now plugging into this built environment.
Yeah.
Now, and the electric utilities have stepped up. I mean, PG&E has been a leader in this, as all the electric utilities have in California. But it's a huge undertaking.
Yeah.
And now that we're getting new modes like aviation coming into it, and we're not talking about just aviation staying with small trainers.
Mm-hmm.
I mean, Boeing and Airbus, they're both working on advanced airliner designs that are going to be probably initially hybrid.
Right.
But the ability to plug that hybrid, these things are going to be giant plug-in hybrids.
Right.
They're going to plug into the electric infrastructure when they're at a terminal, so that they don't have to carry massive battery packs or fuel on board these things, so they can maintain their power during a normal long-distance flight.
It's an exciting time.
It is.
I look forward to flying in one of these.
These are amazing aircraft.
Well, great. I want to thank you for your time and
thank you, Barry.
yeah,
Appreciate it.
it's a pleasure. The Pipistrel Alpha Electro, and it's got a lovely symbol right here. Electric aircraft.
Electric aircraft.
Yeah. Thanks again.
Thank you.